so difficult that you cannot really get your roots. And I told you last time that the nature of the roots tells you about the stability of the system. All our job is to really to look that if there is a feedback control, we want to say if we give the feedback this one, how much is the system stable? If it is this one, how much is the system stable? And last time you did one example in the class where you get the error function. And you have two different values of k. This was the feedback. You see that 1k value gave you higher error. 1k value gave you the lower error. So everything is mixed now. There are several, you should be capable of doing several things. Then you will be able to solve the control problem. Number one, you should know the rules and regulations for block diagram, how to solve it. And I sent you a very nice document which I found, and that's really good document. It tells you all about the block diagram and the simplification, so you get one block diagram. From the simplification of block diagram, you will get the transfer function. In the transfer function, then you can get your CS. Then another problem starts. CS cannot be simply factorized. Then you do like this, then you go back to inverse Laplace, and then the inverse Laplace is difficult. Then you go back to your formulas and see which one is applicable in your case. So this will be applicable here, you complete the square, and then you bring the whole shape very close to this, so that you can recognize your A and B. Once you recognize your A and B, then you are done. In some cases, this will not be able, this characteristic equation equal to 0. Tell me what about the poles of this equation? We do not know. What are the poles of this equation? Tell me what are the poles. I sort out the poles of this equation. So you have some transfer function you need for that. Let's say Rs is 1 over S. Rs is 1 over S. So what you will do? Tell me about the poles and zeros. So let's say Rs is, so the transfer function is, so next part of the question may be like this, that the transfer function equal to what? Output over, right? So CS over Rs, right? Right? Yeah. So you see from here you can get these are the transfer functions. And then from here, let's say that CS is then this multiplied by this, right? So you can put the value of CS there. You can put the value of CS here, which is this one, right? You can put the value of CS here, which is S square plus 1 over S plus 1 into S square plus S plus 2. And let's say Rs is 1 over S, or Rs is a unit function, unit step function, then you will get 1 over S, and that S will be multiplied here. Now you see, it becomes some equation where you can solve it to get your poles, make it equal to 0. So your characteristic equation, you can solve this one. So this is your characteristic equation. Use this characteristic equation, make it equal to 0, tells me what are the poles. Tell me what are the zeros for this system. And from the zeros and poles, the criteria I gave you last time, please tell me about the stability of the system. So do that, please. So write the characteristic equation, which is denominator equal to 0. Yeah, so there is a look, but they all lead to the stability. And there are only two things, error and stability. But it's also stability. Well, that I cannot answer right there because I think they are released. So I don't know. Let me check the, yeah, let me check the polls. There are some questions there about the polls. I gave you the criteria for the poll, for zero value. One of the criteria I gave. So find out the roots of this equation now. Now you can find out the roots, very easy. So put s plus 1, s square plus s plus 2 equal to 0, s plus 1 equal to 0, so s is equal to minus 1, so one root is minus 1. The second is s square plus s plus 2 equal to 0, use the quadratic formula and get the imaginary pole. So you get the imaginary values and then you can plot them in the real end. Okay, so
this is kind of like homework. The poles come from the different differential function in terms of ns, ds. All that means is denominator and numerator. So you take that. The poles come from the ds.
So I'll tell you the page where you have to look for these things.
And you make it equal to 0, and then you solve for the
Oh, just solve for s.
yeah, basically.
Oh, okay.
Solve for s,
Zero
yes.
comes from the front denominator.
Okay.
That is the top one numerator. So you make it equal to 0, and then you solve it.
Right on. Thank
And
you.
then you do a graph where this is JW and this is sigma. And like, I'm not sure how to do like, so for this one, so just put it plus 1 inside, so just do some I here and some minus I, I think.
Okay.
Yeah, I don't know how to do it.
For sure. Thank you. So just set the denominator equal to 0.
So please read page 227 on your book, page 227, about the poles and the zeros.
Thank you.
I have a question on this one, so I'm getting the imaginary numbers for those poles. This one, how do you plot them on this?
Up and down, -1, -2, -3, but they are imaginary.
So for this one, it will be -1/2, so it comes like this way, and then it'll go like right there?
Yeah,
Or-
somewhere here.
Really?
Yeah,
Okay.
poles will go.
Oh,
They will lie on the left hand side or right hand side. Check one example. You can